Hi, this is 7.5, the algebra of matrices. So these are the theorem on matrix properties. So it says that matrices are commutative, the associative property holds, it's got an identity matrix, which is just a zero matrix, and it's got the inverse, additive inverse matrix. So we're also allowed to distribute a constant, or we can take the sum of two constants and multiply that and distribute the matrix A into the sum of those two constants, and we can also move the parentheses so it's associative property for multiplication. So let's apply some of these properties. So first they want us to find the sum of the two matrices. So if you add them, you're simply going to add each of the corresponding entries. So 0 plus 8 is 8. Negative 2 plus 4 is 2. 7 plus 0 is 7. And 5 plus 0 is 5. 4 plus 1 is 5. And negative 3 plus 4 is 1. is 1, excuse me. The next one is a subtraction of two matrices, and we do the same thing. We just subtract this time. So 0 take minus 8 is negative 8. Negative 2 minus 4 is negative 6. 7 take away 0 is 7. 5 minus 0 is 5. 4 minus 1 is 3. Negative 3 minus 4 is negative 7. All right, so let's do 2 times A. This time we're just going to multiply everything in matrix A by 2. So multiply each of the entries by 2. And you should get 0, negative 4, 14, 10, 8, negative 6. And the last one we'll skip, but you would multiply everything in this matrix by negative 3. All right, now we're going to multiply two matrices together, so A times B, and then we'll do B times A to see if it actually is the same answer or not. So we want to check to see if the multiplication of matrices is commutative. So this is the way you multiply two matrices. All right, so you're going to multiply the first row times the first column, and then add up each of those products. So 3 times 1 is 3. So 3 plus 0 times 4 is 0. Negative 1 times 0 is 0. So it's going to be 3. All right, for the second one, you're going to multiply the first row by the second column. So it's going to be negative 15 plus 0 plus 1 is negative 14. All right, that times that this time would be 0, 0, negative 3. All right, now we move to the second row, first column. That's going to be 0, 16, 0. All right, second row, second column. It's going to be 0, 4, minus 2 is 2. All right, next one. 0, negative 8, and 6 is negative 2. And then the last row, first column, that's going to be 5 minus 12 plus 0. 5 minus 12 is negative 7. All right. That's going to be negative 25 minus 3 minus 1. So negative 25 minus 3 minus 1 is going to be negative 29. And the last one is the last row, last column. That's 0. That's 6 plus 3 is 9. All right, so that's how you multiply two matrices. Now let's do the other direction, B times A. That way we'll see if they're equal or not. So let's do first row, first column. That's 3, 0, 0. So that's 3. First row, second column. That's going to be 0, negative 20, 0. So negative 20. Okay, next one would be first row, third column. That's going to be negative 1, negative 10, 0. So that's negative 11. And you can already see that they're not going to be equal. So multiplication is not commutative for matrices. All right, so the next one would be second row, first column. That's 12, 0, negative 10. So that's going to be 2. going to be 0, 4, 0, 4, 6. That's 10. Okay. That's going to be negative 4, 2, negative 2. So that's going to be negative 4, 2, negative 2 is negative 4. All right, last row, first column. That's going to be 0, 0, 15. All right, next one will be 0, negative 4, and negative 9. So negative 4, negative 9 is negative 13. And last one is that one and that one. That's going to be 0, negative 2, positive 3. Negative 2, positive 3 is 1. So as you can see, those two are not equal to each other. So the order in which you multiply makes a difference in the result. All right, now we need to verify this statement. So let's first work on the left-hand side. So LHS. So let's first add up B plus C. That should be, let's see, 2 and 3 make 5. Negative 1 and 1 make 0. 3 and negative 2 make 1. 1 plus 0 is 1. All right, now let's multiply A times B plus C. So that's going to be 1, 2, 0, negative 3 times the matrix that we just got up above. So remember, the way we do that is first row, first column. That's 5 plus 2 is 7. All right, first row, second column, that's 0 plus 2 is 2. All right, second row, first column, 0 minus 3, that's minus 3. And last one is those two, 0 and minus 3. All right, now let's do the right-hand side. I'll do the right-hand side in red. So first, let's do A times B. So we're going to do A times B first. So that would be 2 plus 6 is 8. All right, now we're going to do the next column over. Negative 1 plus 2 is 1. Now we'll do second row, first column. That's 0 minus 9. And last one, 0 minus 3. All right, now let's do A times C. So A times C is going to be 3 minus 4 is negative 1. All right. Next one would be 1 plus 0 is 1. Next one would be 0 plus 6 is 6. And last one is 0 plus 0 is 0. All right, now we have to add those two together. All right, so 8 minus 1 is 7. 1 plus 1 is 2. Negative 9 plus 6 is negative 3. And negative 3 plus 0 is negative 3. As you can see now, the left-hand side equals the right-hand side. So we just verified that the left-hand side does indeed equal the right-hand side. And that